Hello, and welcome to another calculus lesson with Professor Checo. Today, we're going to be focusing on lesson 4.1, viewing systems of linear equations in two variables. So let's go ahead and take that a peek. As always, just going to go straight to the textbook, just see what we need to understand from this major concept here. Alright, so systems of linear equations in two variables. Basically, they're going to start with a basic equation where a system of linear equations in two variables given the linear system ax plus by is equal to h and cx plus dy is equal to k, where a, b, c, d, h, and k are all real numbers, and we have an ordered pair x equals x naught, y equals the initial x and y, is a solution to the equation. So basically there's a solution to this equation as long as there's some kind of something. So there are three basic, let's see what happens next. Basically just going about it graphing, finding the intersection, going about it graphing, and here are three types of solutions. We either have one solution where it's an intersection, no solution where the lines are parallel, or infinite solutions where the lines are on top of each other. Alright, definition, linear solution, basic terms. A system of linear equations is consistent if it has one or more solutions and inconsistent if no solution exists. Furthermore, a consistent system is said to be independent if it has exactly one solution, often referred to as unique solution, and dependent if it has more than one solution. Two systems of equations are equivalent if they have the same solution set. Alright, so that's your basic thing. Exactly one solution is consistent and independent. Infinitely many solutions is consistent and dependent, and if there's no solution, it's inconsistent. Just some definitions we need to be aware of. How to go about it in a graphing calculator. I'm obviously going to use Desmos, and they're just going to go through it, solving it algebraically by plugging one into the other. Oh, what was this? Was this elimination? Elimination by addition is when you can put two variables on top of each other and then eliminate them by, here you go. They are operations that produce equivalent systems. A system of linear equations is transformed into an equivalent system if the two equations are interchanged. An equation is multiplied by a non-zero constant, and a constant multiple of one equation is added to another equation. So basically, if you look at this one, if I want to cancel out the x's, what I'm going to want to do is I'm going to want to have it 15x. No, I'm sorry, they're canceling out the y's. So they want to get the negative 10x and 10y and negative 10y to cancel out. So they're going to multiply both of these terms by the number that's going to get them. As long as you multiply it throughout the equation, it's totally fine. Stack and add, and then you're able to isolate one of the variables. Alright, more solutions, more solutions. If you ever get like fake solutions, if you ever get answers that don't make sense, for example, 0 equals negative 7, which is not possible, that means that there's no solution. That means that these two lines are parallel. They have no solution. So if you look at it, if I multiply this by 2, that by 2, I get 2x plus 6, which means the slope and everything about the equation is going to be the same, but they would have different y-intercepts, which basically just means parallel lines. Applications, how to do it with, if you want to do that, no problem. I'm not in. Supply, demand, equilibrium prices when they're equal to each other. Got it. Just manipulating equations and going straight to the problems. Alright, let's get into it. So, if I'm going to do it like this, then I'm going to be heavily relying on Desmos, which is totally fine today. So here, find the point of intersection of these given 2 points. Well, I can tell you right off the bat, since x is equal to 6, my equation is going to be 6 comma, plug in 6, a third of 6 is 2, 2 minus 1 is 1, so that's going to be the intersection of 6 comma 1. They're just looking for that. Alright, so now find the equation in point slope. That will go through this. We've done this. This is just review from chapter, oh no, I don't know if we've done this yet. Point slope, this is going to be y minus y1 is equal to the slope times x minus x1. You can pick either one of these 2 points. As long as you find the slope of these 2 lines, you're totally fine. So that would be, first, what is the equation of the line in point slope? So it's going to be y minus, I'm going to go with the, oh, I'm not typing. I'm going to go with y minus this first one, 12 is equal to m. Now, to find my slope, it's going to be 12 plus 3 divided by, let's do 12 plus 3 divided by negative 3 minus 2, which gives me a negative 3. So my negative 3 goes out front, x minus negative 3 parentheses x minus plus 3, which is my first coordinate. Cool. And that's just using this point slope formula. All right, match the system of equations below with their graph. So I'm just going to look at this for a second, right? If I multiply this by negative 4, okay, I get negative 16 plus 4y is equal to 0, which means that these two lines should be parallel, okay? Based on that, if these two lines are going to be parallel, I'm going to guess it's either B or D. All right? Now, since this equation y equals 4x is a positive slope, it's going to be that one. So I just rewrote this so that I could do y equals 4x, and you should know from basic algebra that is a slope of 4 that goes through the origin. All right, moving on. What is the solution set? There is no solution. All right, this one, so if I look at this, times negative 2, these two lines are going to have a point of intersection. Let's see. Check this out. If I do negative 3x plus 4y is, oh, do I have caps lock on? I have caps lock on. Negative 3x minus 4y is equal to 3. And my second equation, it's going to be C. What is the point of intersection? I don't know what it is. So let me just do the second line. So then here it would be 6x plus 5y is equal to 3. That intersection is 3, negative 3. Parentheses 3, comma, negative 3. We're finding the point of intersection here, these two lines. Totally fine. Cool. Literally the same exact thing here. Let me just see. This is going to be 2. They're just going to have there'll be something. Just type it in. You'll find it. They're not the same line, so there will be an intersection. Number 6. Literally the same exact thing. They're just on different sides of the equations. There will be an answer. Cool. 7. Oh, they want you to use substitution method. So the substitution method, let me just show you. So when you take this, you're going to have y is already isolated, equals negative 5x. I'm going to take this, substitute it into this first equation, solve for x. Once I have x, plug it back into the second equation to get what y is equal to. And that's how we do it. That's how you would solve it algebraically. So on a midterm, if it asks you to solve it this way, you would have to show the work, right? But then again, you would always confirm yourself and get the question right with Desmos. There's no reason why I wouldn't just graph this and just type it in real quick. All right, so moving on. Same exact thing. This one, addition method. So here's a very simple addition method. If I were to add these two equations, 3x gives me 6x. 10y and negative 10y will cancel out, and then 12 plus 12 is 24. So you have 6x is equal to 24, which means that x is equal to, like you said, absolutely 24 divided by 6, which gives us 4. Now that is going to be 4, comma, plug in 4. That would be 12, so that would be 4 comma 0. All right, you're just plugging it in, working through it. Here, you'd multiply this bottom one or top one by 2. Probably I would do the top one by 2 so that my y's would cancel out. And then you're going to get an answer, plug it back in, pretty straightforward. Number 10, pretty much exactly the same. Here, I would multiply them by 9, and then you're going to very quickly realize that they're exactly the same line. Oh, they have no solution because this is going to be, no, times 9. Negative 45, negative 45, negative 53. That gives me 0 equals 0. There should be infinitely many solutions because that's a true answer. There's no solution. But 9 times 5 is 64. Oh my goodness. I get 0 equals to 1, which makes it no solution. That's right. Wow. Okay. Moving on. All right, so here, very similar problem. You're going to multiply this by 2. That's going to cancel out. You'll have 10. 10, it's going to give you a number. Moving on. Same exact thing here. Substitution, elimination by addition, or substitution or elimination, or you could just graph it. These are all totally possible answers. You're just getting the question right, ladies and gentlemen. Okay, moving on. Solve the system below. Note that the solution can be found mentally without the use of a calculator or pencil and paper calculation. Try to visualize the graph of both lines. So here, this is 7x equals 6. 9y equals negative 2, so it's going to be the intersection of these 2 points, which is going to be 6 divided by 7, comma, negative 2 divided by 9. Did I do divided by? My mouse is there, I can't see. Nope. Divided by 9. Close the parentheses. I need to go on the outside, close the parentheses. Yep, and then, obviously if you need to see it, 7x equals 6, and then you would just find that intersection, and it would work perfectly. Next. Same exact thing here. 5x equals 0, 6x equals 0. These are both vertical lines. There's no solution. This is 5x equals 0, 6x equals 0, x equals 0. They're the same exact line. What are you talking? Oh my god, I did not see this plus and negative. So this is 5x plus y equals 0. And that's 5x minus 6x minus 6x minus y equals 0. Oh, unique solution, 0, 0. If you want, you can go down here, click the points, 0 and 0. Final check. Beautiful. Cool. In a free competitive market, the supply of a good is greater than the demand, the price tends to go up or down. If the supply of a good is greater, the price tends to go down. Price tends to come down because consumers are willing to buy a product at higher prices when demand is lower than the supply. Price tends to come down because consumers are less willing to buy a product at higher prices when the demand is lower than the supply. That's a definition. In a linear equation, so these are all definitions. Discuss the relationship among the 4 constraints and the system has a unique solution. If it has a unique solution, then the slopes are different, which means that n does not equal m. Relationship, it has infinite number of solutions. That means that n is equal to m and b is equal to c. Find the solution. Use a graphing calculator, so just go ahead and graph it. Find the solution. There's going to be one solution. Same exact thing. This is going to have no solution because same slope, different y-intercept. These graph lines will never intersect. This is just going to be decimal, so it just looks like decimal work. I'm not even intimidated. Use the graph. Graph the equations below in the same coordinate. So here you just have to graph these 3. You literally have Desmos to help you. All you need to do is to find 2 points to graph it. You got it. Okay. I'm actually going to do this just so I can see all 3 points. So let's do x minus 2y is equal to negative 10. Let me do 2x plus y equals 10. And let me do x plus 2y is equal to negative 10. Oh my goodness. How am I supposed to see this at all? Is it getting bigger? Nope. Okay, it gets a little bit bigger. So let's see these 2 lines. So this one is going to first go through 0, 5, and 2, 6. So 0, 5, I'm looking at this right here, my coordinate, 0, 5, and 2, 6. There's one line. My second line occurs at 2, 6. Let's go to, what is that, 0, 10 and 5, 0. So let's go 0, 10 and 5, 0. And my last one is going to be from 0, negative 5 to negative 10. Okay. 0, negative 5. Where's my line? 0, negative 5 to negative 10, 0. There you go. Spend some time on it, and we're totally fine. The points in which at least two lines intersect are, so here we have three answers, right? We have negative 10 comma 0. I have 2 comma, what was this point? 2 comma 6. 2 comma parentheses 2 comma 6 close comma, what was my last one? Negative 10, negative 10. Negative 10 comma negative 10 close, enter. Oof. Ten, 0, 2, 6. Oh, this is 10, negative 10. Oops, 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 oops. There we go. Continue. What is true about the solution to the given system of equations? I think there's no solution because there isn't one location where all three lines intersect. Yep. So even though there are multiple solutions, there's no solution to this one system. Alright, so now which of these graphs, which is literally the same exact thing that I just did. So let's see. This one is going to be y equals x plus 7. So plus 7 positive x. Looks like that one. What about this one? This one does have a solution at whatever point that is. What is that? That's 1, 2, 3, 1, 2, 3, 4, 3, 4. It has one solution at 3, 4. No? Oh, negative 3. It's backwards, negative 3. My fault. There we go. Alright, cool. Suppose the supply and demand equation for printed t-shirts for a particular week are given as follows, where P is the price in dollars and Q is the quantity. Boom and boom. Find the supply and demand if t-shirts are $5. So what I'm going to do is I'm just going to go here and I'm going to say y equals 0.5 Q. I'm going to do x plus 2, and then I'm also going to say that y equals negative 1.3 x plus 15. Oh, 1.3 x. So now if x is to find the price supply, to substitute $5 in for Q. No. The number of units supplied or demanded will be given by Q. To find the price supply and price demand, find the supply and demand to the nearest t-shirts are $5. To use the price supply and price demand equations to find the requested quantity, substitute $5 in for P. The number of units applied or demanded will be given by in hundreds, so Q times 100. because Q is the quantity in hundreds. The supply when the t-shirts is $5. So now I'm gonna go right. Let's go x equals 5. X equals 5, just so I can find that intersection. So that's 8.5 times 100. So that should be 850. 8.5 times 100. The supply. Oh, not with x, it's gotta be when y equals 5. Y equals 5. The supply would be 769 units. What do you mean I'm getting this wrong? How would I do this? 7. Did I not do that? Oh, I needed the black line. I'm so foolish. 600 units. I am so foolish. 600. I was using the wrong equation. The demand would be 769. There we go. The stability of the t-shirt market at this price level. So now, because the demand is greater than the supply, that would cause the price to go up. The supply, 13. So find the supply. Is it 153? No, supply is the back. 2200. 2200 units. There we go. Wrong equation. What would the demand for it be? The demand would be 153. 153. 154. Cool. Because their supply is more than demand, you would drop the price. Supply is greater than demand. T-shirts, the supply is greater than demand, the price will tend to go down. Cool. What's the equilibrium price? Right there is $5.61. And what's the equilibrium number of units if you have 722 units in your stock? What would this look like? This would look like the supply curve is going up, the demand curve is going down, and equilibrium point is there. What's the difference between these? No, the supply. There we go. Okay, so here, company markets exercise DVDs that sell for, let me just clear this out a little bit. Okay, $19 plus shipping and handling. The monthly fixed costs are that, and variable costs is that. Find the cost equation and the revenue equation. Alrighty. Well, my cost is going to be 24,500 plus 7.45 x. I'm gonna say that's my cost. 24,500 plus 7.45 x. What is your revenue equation? That's going to be 19.95x, because it's every DVD that you get is that. Y equals 1995x. 19.95x. Cool. How many must be sold in order to break even? I'm going to just subtract minus, right? Pretty straightforward. 1960. Choose the graph below. Oh, my scale is really, really, really off. I mean, they both kind of seem like they're going up. This happens at around 39,000. If that's 80, 39, probably a little bit lower. Look at the intercepts. Oh, they both have to be. One of them goes to the origin, the other one starts because it's a upfront cost. There we go. My bad. Cool. What does the region between the lines and to the left of the break-even cost? That is when you're not making enough money. The loss when X DVDs are manufactured. What's the region to the right? It's going to be the profit when X manufactures. All right, so United Express, a national packaging delivery, charges a base for overnight shipping £1, and customers bill $26 for shipping a £6 package and $68 for that. Find the base price and the surcharge of each additional pound. So what we're going to do here is we're going to kind of think of this as like a step function, right? So charges a base price for overnight delay. So we know that they both have y equals mx plus b. So really what we're trying to figure out is what is the b, right? So a customer is charged $26.75, and then the next one is $68. Oh, it's a big jump. 66 pound and 31 pounds. So let's figure this out. So that would be $68 minus $26.75, and I would take all of that and divide it by the change in weight, which is 31 minus 6. So that means that we are charged $1.65 per pound, right? But I still don't know what the y-intercept is. So if I go back over here, I know that my m is equal to, well, I'll just plug in b. Let's do 68 divided by, well, what's my slope? 1.65 times 31. And that's what b is equal to. So b is equal to $1.33. The base price is $1.33. $26.75 for shipping a 6-pound package. $68 for shipping a 31 package. You find the rate of change. It's $1.65 per pound. Why did I? Y is equal, oh, mx, not divided by, minus 1.65 times 31, 16.85. Oh, that was foolish. 16.85. Check. No? $68 mx, right? M is $1.65. X is 31 pounds. Is equal to B. Final check. 1850. How did they get 1850? 2675, 2675. Let's view an example. Let's see where I made a mistake. First, translate it into the equation. Yep, I got that. 43 is equal to 4m because it's 4 pounds. Oh, 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 oh. Oh, still the same thing though. How did they get 4m? M is the surcharge. X number of pounds. The package weighs over 1 pound. Okay. Okay. Now solve the system of equations. So if I were to go back to my... Okay. Okay. And then I get M. Plug it back in, find B. So let's do this one more time. Let's see. I'm curious now. Let's pique my interest. Let me look at this first equation. So my first equation is 1685 is equal to how much is this thing? It's 3 pounds, 3x plus b. And then let's do my second equation is 53.10 equals 28x plus b. And if I just change that for y, the base price I forgot the x. Alright, so let's say the base price is $12.67. Yeah, why has to be that? So why am I not right? 12.66, 12.67, 12.50. Why 1685? Oh, because it should have been 28. Oh my god, this is so tricky. 12.5. Alright, and then the surcharge would have been $1.40. 1.45. Okay. That was actually really... Alright, so I'm going to do that one more time. So here it's 25.50, and for 4 pounds, and then it is 60.50 for 24 pounds. And then if I just click this, that's going to be 18.5, and then each additional pound is $1.75. Oh, not the 3. What did I put a 3? Cool. All right, that makes a lot more sense. All right, so let's see. A pound of the robust blend. A coffee manufacturer using Colombian Brazilian coffee beans to produce 2 blends. X is going to be Colombian, Y is going to be Brazilian. A pound of the robust blend. So let's just do let's do 1 equals 12x plus 4y. So this is a pound of the mild blend is 1 equals 6x plus 10y. Okay. Now, coffee is shipped in 58-pound burlap bags. The company has 58 of Colombian beans and 36 bags of Brazilian beans on hand. How many pounds of each blend should they produce in order to use all the VAT? Well, 58 plus 36. What's 58 plus 36? 94. What if I change this to 94? And if I change this to 94? Oh, what's half of 94? Half of 94, 94 divided by 2 is 57? 47. So let's do 47. And let's do 47. How many pounds? Round each to the nearest pound. 3 and 3. Alright, let's do this one more time. Total weight 41 bags. Oh, it tells us how much they're each in. So what did I do here? 87-pound bags. No, that's not right either. I'm gonna view the example. These questions down here are not fun. All right, so let's see. Convert the ounces of Colombian beans required by dividing each number by 16 to get the weight in pounds. Okay. Then your Colombian beans are gonna go. Oh, it's gonna be how much of each one is gonna be the Colombian beans. So this would be how much of X. This would be how much of Y. And then the total pounds of beans because you'd multiply them. And then there you go. And you're just going to put X and Y, and then you're going to get the equation. I understand now. Once you have the equation, you do that. You just graph it, get the equation, find out how much of X, find out how much of Y, and then you have your answer. All right, that's totally understandable. Cool, I'm going to skip that question because the viewing example is pretty straightforward. All right. Animals in an experiment are to be kept under a strict diet. Each animal should receive 35 grams of protein and 5 grams of fat. The laboratory technician is able to produce 2 food mixes. A mix has 30% protein, 6% fat. B mix has 50% protein and 5% fat. How many grams should they mix in order to get the right diet for one animal? Let's go to the viewing example. All right, so to find, we got to figure out how much of, so here it's 64 grams of protein, 10 grams of fat is what they need, 40% protein, and that's what they need. So since mix A is 40% protein, the animal receives 0.4 grams of protein from that as it eats 70 grams. And then the other one is going to be 0.5, so that means 0.4 plus 0.5 would have to be equal to 64. And then same thing for the 10 grams of fat. Find that system of equation, solve for that. Then it's going to tell you exactly how much we should have of mix 1. Plug that back in to find how many grams of that of mix 2. 80 grams of A and 80 grams of B to have the correct diet. Complicated, but with the help of the viewing example, solvable. Last question. Bill Lute's dog is on a strict diet. The dog is to receive, among other nutrients, 40 grams of protein, 8 grams of carbohydrates. Bill only has 2 food mixes available. Very similar. So here, we would have to do 0.3x plus point. What do they keep doing for this setup? 0.3. So here's the percentage, the percent you get from B. Yes, from X, from Y, and then that what you need it to be. Second equation from X, from Y, what you need it to be. Two equations, solve for the missing link, and then you'll get your answer of what it should be. All right, cool. Again, pretty straightforward now that we kind of see it, and hopefully that makes a lot of sense. About 40 minutes I went through this and skipped a bunch of questions, but I have faith in you guys. Best of luck. If you have any questions, reach out.